Hey everybody, welcome back to Tech Junior Tutorials. I'm Lee Warwick Jr. and we're doing Advent of Code. Today is day 6. I'm smiling because it's actually the morning and I've solved this thing. Did not ever think that I would solve one of these that fast. They've just been kind of kicking my butt every day so far. But today I woke up and kind of, I don't know, I hit a stride or something. So let's let's talk about it. So here's the instructions for day 6. Today we're talking about orbitals. Yeah. So planets orbiting other planets. There's something to do with checksums. I don't know what that is, but thankfully they gave us some test inputs to work with. So that was crucial for finding a solution relatively quickly. And then they gave us a really good visual of the problem. So basically, what we have to do today is we have to find direct orbits and indirect orbits all the way down to the center of mass, which I'm guessing is like center of the universe or something. But in any case, so we've got, for an example, let's say we're starting at L. L directly orbits K, and then K directly orbits J, but then L is also indirectly orbiting J. So it's like this count backwards problem where you have to find every endpoint and count backwards to the center of mass. And those transitions are, or those steps or jumps, wherever you want to call them, those are all orbits. So here they've done a favor for you and like put these all in order. So L goes to K, K goes to J, J goes to E. And then there's no repeats in here. So if you go from L to K, K to J, J to E, there's no E to D twice. So that's not repeated in this list, which is another crucially important thing that I kind of landed on reading this morning. So the values on the right-hand side should all be unique. So that was instrumental. That told me that I needed to use like a dictionary for this, or an object or hash map or whatever the heck you want to call it. So basically, I wanted to store keys, which are on the right side of this end parentheses. And then if you do a lookup on one of these planets, and that lookup gives you another planet, and if that other planet is not in this list on the right, that means you've hit the center of mass. So if you look at COM here, it only exists on the left-hand side. So once you hit that and do your lookup, and your lookup is not in that list of things on the right, that means that you're done. So you only have to traverse this thing one time, basically, to get all of your orbits. So, again, back to the example, that's the list of inputs. Here's the mapping. And then they tell you, which is really nice, the answer for this map here is 42. So if we jump over to my code, I went and took that list of inputs that they had, and I put it into my code as a test input so I could run my my program against that and see if I was getting the expected output. And then once I hit that 42, that would tell me, yeah, you've got it. So first I create the dictionary, and then obviously, just like all the other examples, I'm reading from a file. So I grab all of that input data, which I've stored in a text file. So there's 1,035 at least direct orbits right off the bat. So your answer has to be more than that. But anyway, so I put that in a text file. I read from that, and then I can I convert that into a list of inputs. So then I first loop over that list. I unpack the orbit and the planet. So the thing on the left is the thing that's being orbited. The thing on the right is the planet. So I've got it in that order. Python really makes that nice with unpacking. I would use destructuring in JavaScript to do the same thing. And then I store the planet in the orbit dictionary, and the value is going to be the orbit. So once I've got that, that's like the main part of the puzzle. Then I just have to kind of walk that list, or walk that dictionary, all the keys in it. So I start with 0 orbits, and then for each planet in the orbit dictionary, I grab its direct orbit, and that's going to be 1. And then from there, I have to find all the indirect orbits. So there, I just do a while loop, which is kind of dangerous, but I'd basically traverse until I've found the center of mass. So if the next thing in that dictionary doesn't exist, then that's basically COM. So I've hit that and I'm done. So every time that I don't hit that, I just count up again. So that should be all we need for part 1. So let's go ahead and we'll try that with the test input. Let me clear this. Whoops. Oh, I've got my part 2 solution down here. So let me comment that real quick. So when we run that, we can see that we get that 42 number. If we come back and comment that out, we'll be working with the real output. That gives me 147,223, which is the number that I was looking for. So now part 2 is pretty interesting. So now, instead of just counting the total number of orbits, we need to find Santa and like what planet he's orbiting. So that now they give you a list where you've got you and Santa. And so before we even do that, like I had to go into the inputs and say like, hey, oh yeah, I am in there, and oh my gosh, Santa is in there. And I didn't even realize it, but they have COM in there as well. So you could have looked explicitly for COM instead of checking if something wasn't in your dictionary, which was an interesting note, but I didn't realize that until I was done with the puzzle. But in any case, so you're looking for basically the path from you to Santa and how many steps that would take. So in this example, you start with the planet that you're orbiting, they say, and you want to find the planet that Santa is orbiting. So they say your path should be from K to J, J to E, E to D, D to I. So that would be 1, 2, 3, 4 in order to get from you to Santa. Then they give you this extra bit of information, which is totally useless, doesn't matter for this problem at all. They're just saying that afterwards you both should be orbiting the same planet, but again, that doesn't even factor into the solution. So again, looking for the steps from your planet that you're orbiting to Santa's planet. So looking at this problem after solving the first one, I knew that there were some certain steps that I had to take programmatically to get this done. And I think maybe for the first time I've like pseudocoded something for this solution. Let's go ahead and look at that real quick. And we'll uncomment. I did the same thing, by the way, for part 2, where I grabbed this list and turned it into a list in Python, and then use that to test my solution against, because I know that I should get an answer of 4. So that, again, was critical for finding this quickly, instead of like testing my program against, hopes and prayers. I actually had an input, and it seems like every puzzle so far has had some kind of smaller data set that you can use to check what your answers are. So like, depending on how great that example is or how great that test data is pretty critical for how fast you can find the solution. So like for day, I think 4, where they give you the test solution, which is like 3 numbers. And they're like, oh, you're only supposed to find 2 adjacent digits that aren't matching a pair of larger digits. These examples don't really help a ton. So one that would have really helped would have been like 12444 for that one. 124444. And saying that that doesn't count. That would have been a really great test case to help you find that faster. But luckily on day 6, we've got a really great set of test cases right off the bat. So yeah, let's plug that one in and see where we get. So we've got com, and then at the very end, you and Santa. So same data set, but here's the paths that I knew that I needed to take in order to crack this one. So first, I have to find myself and find what planet that I'm orbiting, not ordering. Then I need to find my path to the center of mass. I don't know if I actually needed to do that. That doesn't really factor into the solution, but I figured like that's going to give me a definite like tree of paths all the way back to the end. So then I store that path, then I find Santa, and then I'm going to traverse towards the center of mass as Santa until I hit that common planet that's in my own path. And then I'm going to store that number of orbits from Santa to that common planet, and then I'm going to go back to my path that I've stored and count until I hit that common planet. And then when I add those numbers together, I should get my path to Santa. So let me uncomment all this, and we'll see how I did that. So first, I made my path as a list. I found the planet that I'm orbiting by doing a lookup for U in the orbit dictionary. And then I found Santa's planet by doing the same thing. Then for my path to the center of mass, I did the same thing as above, except instead of using a counter, I just appended each planet that I'm hitting on my way to COM in path. And then I did store center of mass in that path, but again, that didn't matter because I was looking for that common planet. So then I find Santa's path to the common planet, so I do this while loop again. I also added in basically a failsafe where if I eventually hit COM somehow, like this loop would just stop, but that never happened, luckily. So I started with 0 for Santa steps, and then did the same traversal that I used from part 1 and finding my path, and then just counted steps instead of storing to a list. And then I did an additional check and said, hey, if that thing that I'm orbiting is in my original path, go ahead and save that as the common planet, and then break. So I get the common planet, I get Santa steps to get there, and then I need to trace my steps to the common planet. So now I'm going to loop over my path, and then I basically just do a counter and say like, hey, until I've hit that common planet, add 1. And then add those together, and that's it. So using the test data, all the way down here. If we run that, you'll see with the test data, so I started at K, Santa started at I. So there's K, Santa's at I. My path to center of mass, JEDCB. JEDCB. Santa's, the common planet between Santa and I is D. And then Santa's steps to get there 1. So from I to D is 1. So you can already see like how much test data is available to let you know that your program is running correctly, just using this small data set. So like that made this problem a lot easier versus like day 4 where you've got an ambiguous set of instructions and then like some not really great test cases. And that makes it like super hard to solve that one. So then I just traverse my own path, and so I go, if the common one is D, J, I start at K, so K to J is 1, 2, 3, and that's that number, and then 1 plus 3 is 4, just like in the example. So with all that going, if we comment out my part 2 test data and then run that, you can see there's the common planet. Santa took 94 steps, I took 246, and if you add those together, you get 340, which was my answer for today. So that's all for day 6. I again am just like really am patting myself on the back that I was able to get this one that quickly. Especially after day 4, where I was like in the pits of despair, thinking like, man, why am I even programming? Because I can't do this simple traversal of numbers and find like one set of double digits or something like that. So this pathfinding stuff, it looks hard when you look at it, but if you're using the right data structures, that's really critical, which I think is something that I've learned doing these puzzles so far. So with a massive data set, you can do something like use a bunch of lists or arrays in JavaScript for something like the orbital puzzle, and absolutely like slow down your program. The pathfinding from day 3, like if you're using lists for that, it's almost impossible to find the answer, because you're going to have like billions of data points, and it's going to take your processor forever to run that, or it will just like never finish. So like on day 3, I ran into that problem where I had a really bad, inefficient solution, and I could do it with a small data set and get the answer, but as soon as I ran the larger data set, that exponential growth of data points just slowed everything down until I would never get an answer. So I've kind of discovered that there's some value in learning data structures. So that's definitely been a real help. And then that and reading the directions and making sure that you have a crystal clear understanding of what the requirements are to get the answer has been also like absolutely crucial to solving these. So know the requirements, get some small data sets that you can test against, and once you've got those two things, then the solution's just a matter of finding the right way to get there in whatever programming language. So I think that's really a critical strategy for this. I could see these helping if you're applying for like Google or Facebook or any kind of company that has these sort of challenges. Doing these would really get you a lot closer to being ready for that kind of interview. If you're walking into these kind of things blind and you've never done them before, you're toast. Just like I was on the first couple of days, spending like hours and hours trying to do them. So I think there is some value in them. I still wouldn't recommend these for a super beginner to a programming language. Like if you programmed before and you want to do this in a new language, I think that's great. It's really helping me learn Python and how to like wrap my head around the basic syntax. I'm not really doing a whole lot of real world stuff with it aside from these tiny problems, but it's at least a fun way to learn a new language once you get past like the initial hump of like having to look up literally everything that you're doing. So that's been really fun. All right, that's all I've got. I don't know if I'll be able to do days 7 and 8 because it's going to be Saturday and Sunday, and we're getting close to Christmas, and that's like a time for looking at Christmas lights and all that good fun stuff. So we'll see how it goes. But I will see you on the next video that goes up, and hopefully you're doing pretty well on Advent of Code yourself. Like, subscribe, follow, all that good stuff. Hit us up on Twitter at TechJR Podcast. Let us know how you're doing with Advent of Code. You can find me at Lee Warwick Jr. And good luck to you. All right. Bye.